Uh, Good afternoon, dear learners. Okay, I hope my screen is visible and my voice is audible. Okay, thank you. So welcome to this fifth session on the topic loop statements for the course Fundamental of C Lab. My name is Shirish Nagar and I'll be taking up this session. So the guidelines for making this session more interactive is to maintain discipline for smooth conductance of the interactive live session. All the learners must type in their name with enrollment number and program name on the chat to mark their attendance. You can raise your queries and doubts after the completion of the session without interrupting in between. Okay, so till the last four sessions, we have seen few programs, several programs, I must say, and for different programs like addition, subtraction, using uh, the conditional statements if else, if else if ladder, nested if switch case, right? Variable declaration and other logic development programs, relational operators, greater than, less than, finding smallest, finding greatest of three numbers. All those programs we have seen. We have seen logical operators, arithmetic operators. Okay, all these programs we have done. Today we are going to see, and we have also started with the loop control statements. So in this session, we are going to discuss more programs or learn more programs for loop control. So last time we have discussed loops like while loop, for loop, do while loop. So what are looping statements? For revision purpose, I'm just mentioning this that the loop control statements require us to repeat the execution of several statements or block of statements, and the number of times a body of a loop gets repeated is called iteration. Okay, so iteration is the number of repetition that your loop does or your loop body does. That is called iteration. Okay, so in C language, there are two types of loops, two categories of loops. First is called pre-test and the second is called post-test. In pre-test loop, or they are also known as entry control loop, we check the condition first. Okay, if the condition is true, then only the statement inside the loop will be executed. Okay, if the condition is false, the statements will not be executed and the loop will be bypassed and subsequent statement after this will get executed. So before you enter into the body of the loop, it is necessary to evaluate the condition first. If the condition is false, then you have to come out of the loop. Okay. And it also means that you will enter the loop for the first time before only after verifying the condition. So it may happen that right in the beginning, the condition is false. So the minimum number of times this pre-test loop will run will be 0. Okay, this is the minimum number of times a pre-test loop will work. Example of pre-test loop or the types of pre-test loop are while loop and for loop. Okay, so while and for are the loops which are pre-test loops. Means it is necessary to evaluate the condition before executing any statement inside the loop. Right? Okay, then we have got post-test loops. So post-test loops are the loops where the statement is executed first, and then then a condition is checked. So you evaluate the statement, you like execute the statement, and then check the condition. But next time when you grant the access to this loop, uh, you have to check the condition. Okay, so minimum number of times this post-test loop will work will be 1. Okay, so because it will run at least once, even if the condition is false. Even if the condition is false, the minimum number of time the post-test loop will run will be 1. Okay, it will run, and then it will check the condition later. So there are, for example, there are two types of shopkeepers. Okay, so there are two types of shopkeepers. So first is very strict and the other is kind. Okay, so the strict shopkeeper, what it will say, you give the money first and then take the item. For example, you go to a shop and you ask for anything. So the shopkeeper will say, first give me the money. It means that if you have money, then only I will give you the item. Okay. So if you don't have money, that is the condition is false. He will not allow you to take the item from his shop. So condition is checked first. Then there is other type of shopkeeper, your familiar one who knows you. Okay. They are kind persons. You go to the shop, ask for a chocolate. The shopkeeper will say, take the chocolate. Don't worry. Even if you don't have money, take it. But next time, bring the money. Next time, if you don't have money, you will not get chocolate. So first chocolate is for free. Okay. So the minimum number of time the statement will run here will be 1. In the case of post test, means the condition will be checked later, but before that the statement will get executed. Okay. So these are, and the example of this post test loop is do while loop. Okay. So it is do while loop. So let's try them. I think we have already done examples of while loop. So what is the syntax of while loop? There is a keyword called while, and then in the parenthesis, you have to mention a condition. A condition in form of an expression. Expression means it will contain some arithmetic and logical operators, and it will ultimately return a Boolean value. So it will return a Boolean value. It means it will either return true or it will return false. Okay. So if you have a true value, then only the statement will inside this curly bracket will work. Otherwise, it will not work. Okay. As soon as this condition becomes false, you will come out of the while loop. Right? So here there we have seen an example in last lab session. So here let's say int I is equal to 0 and while I is less than 3. Okay. So printf hello. So here the initial value of I was 0. So here I and output. So I was 0. So first you check the condition is 0 less than 3. So yes, 0 is less than 3. So what I will do, I will have to print hello. Now in this body, I will increment the I with 1. It means I is equal to I plus 1. So the next value of I will become 1. Previously it was 0, now it has become 1. Again you go back, check the condition. Is 1 less than 3? Yes. 1 is less than 3. So again you will print hello. Then again you have printed hello. Again you increment the value of I. I will now become 2. Again you check the condition 2. Is 2 less than 3? Yes. So again you print hello. Again you increment the I value as 3. So is 3 less than 3? No. Wrong. So you will come out of the loop. In this process, how many times you have printed hello? 3 times. So this will be your output. Okay, so here you are checking a condition. This is called condition. Okay, and we refer this variable as counter variable. It is also known as loop variable, which ensures or which is responsible for maintaining the number of iterations of the loop. Okay. Okay, is it clear? Is this program clear to you? So we have done this program last time. Then we have seen a program to uh, display the sum of natural numbers. Okay, so display a sum of natural numbers means how do you calculate sum of natural numbers? There is a formula n into n plus 1 by 2, right? But we don't use this formula. What we are doing, see here. So first of all, we are declaring some variables. First is n, I is equal to 1, sum is equal to 5. Now we are asking a user to enter an integer. So let's say I enter 5. Okay. So now my n will become 5. N is not less than 0, so if condition will be skipped. So while I is less than n, what is I? I is 1. Is 1 less than 5? Yes. So what will happen? Sum plus equal to I. It means what? Sum is equal to sum plus I. So what is sum? Sum is 0. Okay. So new value of sum will be 0 plus 1. That is 1. So sum is what? 1. Now what will happen? I plus plus. So I will become 2. Is 2 less than 5? Yes. So sum is equal to sum plus I. Means sum is equal to previous value of sum was 1, 1 plus 2. So now sum is 3. Okay. Then again I plus plus I will become now 3. Is 3 less than 5? Yes. So what will happen with sum? Sum will be 3 plus 3. Previous value of sum was what? 3. So new value of sum will become 6. Okay. Then again I plus plus 4. Is 4 less than 5? True. So what will happen? Sum is equal to sum plus I. Means sum previous value of sum was 6. I is now 4. So it will become 10. Right? Then I plus plus. I plus plus will make I as 5. Is 5 less than 5? No. So what is the sum of first 5 natural numbers? 10. That is 1 plus 2 plus 3 plus 4 plus 5. Okay. So like this we calculate. Okay. So here 10 plus 5 will become again 15, right? Because this 5 is less than equal to 5. See what we are checking. Less than equal to, right? So it will also check for equal to. This will also check for equal to. So 10 plus 5 will become 15. So the final answer will become 15, not 10. Okay. So 1 plus 2 plus 3 plus 4 plus 5 is 15. So that is sum of first 5 natural numbers. Okay. If you calculate by using this formula, you will get the same answer. 5 into 6 divided by 2. That is 15. But we want to learn loops. That is why we are not using this formula. Well, this example we have done in last lab. I'm just revising it. Okay. So now we are going to do another example, where we'll ask the user to ask for party to user until the user say yes. So we are running the loop for infinite times. That is why we are using 1. 1 here means true. So it will run this loop infinitely. Infinitely. But we have to come out of this loop. So for coming out of this loop, we will use a statement called break. This will exit the loop. Exit the loop. But when we have to exit the loop, if the user say yes, we will ask the user every time, do you want to have a party? We will ask the user to enter a character response. If the user enters Y for an answer, then we will printf and will break. Otherwise, we will keep on repeating the same loop. Okay, let's do this program. Can you see the code blocks screen? So here we'll take a new file. Okay, so I have created a new file lab5.c. Anyways, so here include stdio.h. Okay, now in this main, so here what we are going to do is we are going to declare a character variable as a answer. So whatever answer user gives, it will be input as character. So here we are going to run an infinite loop. So there are different ways of running infinite loop. Either we can write while true, or we can write while one, or any value we can write. So here one means true, zero means false, right? One while one means true. So every time one is true, so it will run the loop. It will run the loop infinitely. Okay. So this is an infinite loop. This is an infinite loop, right? So here what we are going to do is we are going to ask, do you want to go to party? Okay. Answer yes for yes. No, we are not going to accept. Okay. Whatever other character the user types, we will not entertain. We will keep on asking the question again till the user says yes. If so, now whatever user types as an answer, we have to scanf in our variable as answer. Okay. In this variable, we are going to store it. So if the answer variable is equal to y, if the user types y, then what we have to do? So we will acknowledge him. Printf, great. We can go for party. Okay. So this we are going to type. And then after that, what we will do in that same line, we will break. So break will make you come out of the loop. Okay. So make will take you out of the loop. So by writing break, what we are going to do is we are going to exit the loop. Okay. So the loop here terminates. We'll write here return 0. Okay. So let's run this code, see if it works. Scanf. Okay, I have to put semicolon here. Good. And then semicolon here. Okay. So let me share my screen, output screen. So here the answer, it is, I type any value. So if I say yes, great, we can go for party. Okay, now it has come out of the loop. Okay, so it is typing again and again. There should be some problem with that. So we can alter this code. It is asking multiple times this character answer. I'll put a space here. Let's see if it fixes the issue. Okay, now it is fine. I have put a space here and this solves my purpose. So whatever I type here, it is not accepting as an answer. I'm typing different values, I'm not typing just y. But as soon as I type y, it comes out of the loop. Okay. Can you see the output screen? Okay, you now you can try the code yourself. I don't know if this copy pasting works. Okay, so Bhumin is saying that it is working. Okay, it's working. Shani is saying that it is working. Okay, good. Are others trying? Please try. Okay. Amina is also saying it is working. Great. All right. Well, I believe you have now been able to understand how this loop works. Okay. So whatever condition you are evaluating, you have to mention here. Okay. So if you want to continue doing the same thing, you have to put that condition in here. So it is an infinite loop basically. Okay. So likewise, we will also check for other loop constructs. So there are two other constructs left. First is do while loop and second is for loop. So first, let me give you a hint on what is do while loop. So in that case, for do while loop, so for do while loop, what is the construct? If you look at the construct of do while loop, you will write whatever you want to execute in the do block. So in the do block, you will write whatever statements you want to execute. So statements will get executed even if the condition is false. So after this do block closes, you write while and then you mention the condition. And now, most importantly, put a semicolon here. So this is how the do block works. So in the do block construct, you have to write whatever statements you want to execute. Okay, and then you have to write the condition here in the while part and then put a semicolon. Okay, in while you don't put semicolon at the end, but in do while you put a semicolon here. Because what happens, see, these statements will get executed first. Okay, so even if this condition is false, no one is going to bother. It will execute these statements at least once. Okay, at least once it is going to execute these states. So let's implement the same program but using a do while loop. So I don't have to make too much of a change. Okay. So here what I will do is I will put this condition at the end. I will put it at the end here, and this all conditions I will write in do. So that makes do while. Okay. So here again it is an infinite loop, no doubt. But minimum number of times it will run is once. If this condition is false also, then also it will run for once. Okay. So if I write while 0, so let's see how many times it works. First of all, let us run this program. Okay. So let me share my output screen. I hope you remember that I have given while 0. While 0 means 0 is false, right? So even if, uh, so can you see this statement? This statement is executing even if while is not going to work because the condition mentioned is for false, 0. So it has at least printed this statement once. Even if I give E here, it will terminate. Why? Because it is while 0. So while 0 will not allow me to again come back into the loop, but it has executed at least once. Okay. So it is running in spite of me giving the condition as false because I am running while 0. While 0 is not going to run. It is false condition. So false condition loop will not work. Okay. So now what I do is I will run it for one while loop 1, and then I'm going to do the same business. So here, let me share the output screen. So it is asking, do you want to go to the party? So answer Y for S. So again, it is running the same thing. So as soon as I enter Y, it comes out of the loop. So this is how the do while works. So do while executes even if the condition is false, at least once. Okay. Okay. Is it clear? So try this code at your end, see if it is working. Let me know if this code is working at your end. Okay. Who else is able to execute? Okay, except women. No one. There are 25 participants. Only two or three are giving answers. The problem is many of you have joined this meeting from cell phone. It is a lab session, so all the participants at least should place themselves in front of a computer where you can appreciate the working of the program, because it is a lab session, it's a hands-on session. So participants are recommended to try this code on their system, preferably on a laptop or on a desktop. But like attending lab sessions on mobile will not uh, be good, because will not be effective. You have to practice programming. Okay. All right. So some students are responding that this code works. Okay. So most of the participants were able to understand the do while loop. Let's go to other category of loop, which is for loop. So in for loop, it is similar to while loop. In for loop contains three parts. The for keyword has to be written. Then the initialization of the loop variable has to be done. Then condition has to be checked. So there is a semicolon here. Condition has to be checked, and then we have got increment or decrement operations C. So how many times this loop will run in increment and decrement of loop variable. So initialization of loop variable, condition checking, and increment or decrement. So all these three parts are optional. So if you don't initialize, you have to put semicolon if you don't want to increment decrement. So condition is mandatory. And if you don't supply condition, then the loop will become infinite. Okay. So if I am writing a loop like for like this, so this is an infinite loop. Okay, with two semicolons here, because neither there is initialization, nor there is condition, and nor there is increment decrement. So if these three things are missing, it will become infinite loop. So here we are doing an example for an experiment where we are going to print letters from A to Z and backwards Z to A. So printing from A to Z is incrementing, and printing from Z to A is decrementing in terms of their ASCII values. Okay, so what we are doing is we are declaring a character as C, and first we are printing from A to Z. So printing from A to Z, how we will print from A to Z? We will initialize our character with A. Until the character reaches Z, we have to keep on incrementing its ASCII value. And every time in every iteration, we will print the character. So when we increment the ASCII value of A, it will become B. If we increment the ASCII value of B, it will become C. If we increment the ASCII value of C, it will become D, until Y will be incremented and will become Z. So starting from A, we will keep on incrementing till we reach Z. So once the character is equal to Z, we will come out of the loop. And by until that time, we would have printed the letters from A to Z. Backwards, same business. So here we will initialize the character as Z. We will continue decrementing till the character reaches A. Character is the ASCII character is greater than equal to A. We'll keep on doing it, and we will decrementing it. So this is decrement. So this is C is equal to C minus 1, means character's ASCII code is decremented every time. So Z minus 1 will become Y, Y minus 1 will become X, right? And B minus 1 will become A. So from Z we are printing till A. Okay, so this is a simple example. So here in for loop, if you see closely, there are three parts. This is called initialization. Okay, this part is called condition, and this is called increment. In this case, it is decrement. Okay, because it is subtracting by one. So let's execute this code here. So what we will do is we will declare a character, let's say C. Okay. Now what we will do, first of all, we will print from A to Z. Okay. So print F, print letters from A to Z. Okay. So letters from A to Z we are printing. How we will print for C is equal to A. Okay. So first we have initialized our character to A. Then C is less than equal to Z. Continue incrementing the character. And in every increment, what we will do, we will print that character. Okay, we will print f percent c, that character. Okay, every time we will print that character. No need for again increment, because increment we have taken care here only. Okay. Now similarly for printing from Z to A. So printing from Z to A, what we will do? Z to A. So for printing from Z to A, we will initialize our character to Z. And till it is greater than A, we will continue decrementing it, and we will print the character every time. Okay. So this is the logic. So let's run this code, see if it is working. Oh, semicolon problem. Semicolon problem. Okay. Yeah. So this is the output I am getting. Okay. So this is the output I am getting here. Right. So from letters from A to Z, it is printed because it has incremented the ASCII value every time in the loop. From A it became B, to B it became C. So it is continuously incrementing the ASCII value of the character. I have already told you that integer and character can be used like interchangeably. Okay. Wait a second. Yes. So now you can try at your end, see if it is this code is working. So I have shared the program on the screen. Let me know if you are able to execute this code. Try it at your end. Okay. How many students were able to run this code? Only one. That's not fair actually. Other students should also try. Only one or two students respond. This is not appreciable. This is a lab session. Please try this code. Okay. Amina has also confirmed that it is working. Who else has tried it? Okay. So I have given this code. You can take a screenshot of this code. See if you are able to uh, make it work after some time. So now we are going to another interesting example. So here we are going to check if a number is palindrome or not. What is palindrome? Palindrome is any word or any number which is same when read backwards. Okay. For example, we have words like eye. So either you read it from left or right, it's same. Like peep, same. Deed, same. No, in numbers 1331, 1111, okay, 22. All these numbers are same when read either backwards or from forward. Okay. So how to check if a number entered by a user is a palindrome? So what is the logic here? First, we reverse the number. Okay. We reverse the number and then we compare it with the original number. If after reversing and the number is same as that of original number, we can say it is a palindrome. But how to reverse a number? Okay. For reversing a number, we divide the number by 10 and we store its remainder. For example, we have number like 707. You know it is a palindrome. So what you will do is you will calculate remainder. How will you calculate remainder? You divide 707 by 10. Okay, what is the remainder? 707 divided by 10. What is the remainder? Yes, the remainder is 7. Okay, so now you calculate a reversed value. What is reversed value? Reversed value multiplied, previous reversed value was 0. Okay, so previous reversed value was 0, reversed multiplied by 10 plus remainder. So previously the reversed value was 0. So 0 multiplied by 10 plus 7 is the reversed value, which is 7. Okay, now what you have to do? You have to shorten the number by dividing it with 10. So in the next iteration, your new number will be n is equal to n by 10. So 707 divided by 10 will give you 70 as a quotient. So now your new number is 70. Again, you calculate the remainder by dividing with 10. So 70 divided by 10, the remainder is 0. Okay. So now what you do, you add 0 to your previous reversed value. So previous reversed value, you will shift it to the tens position. So reversed will be 7 multiplied by 10 plus 0. That is 70. So now your reversed value is 70. And now you shorten the number by dividing with 10. So 70 divided by 10, the quotient is 7. So now your new number n is 7. Now you check the remainder. 7 modulo 10. So 7 modulo 10 is what? When you divide 7 by 10, the remainder is, when you divide 7 by 10, the remainder is what? No one is replying. Poor mathematics. So when you divide 10 by 7, it goes 0 times. So the remainder is 7. Clear? So remainder is 7. Now you will add this remainder to your previous reverse number. So previous reverse number is 70. So 70 plus 7. Okay. So what you do is 70 into 10 plus 7. Sorry. So 70 into 10 plus 7. So that is 700 plus 7. So that is 707 is your new reverse number. Now you shorten the number by dividing it with 10. So 7 divided by 10. The quotient is 0. Now we cannot continue in this loop because we have to go till n is uh, not equal to 0. But now n has become 0. So you have to come out of the loop. Your reverse number is now 707. Is it the same as the original number? Yes. So since the reverse number is same as the original number, the number entered by the user is a palindrome. Okay. The number entered by the user is palindrome. If it would not have been that case, then number entered was not a palindrome. Okay. So let's try this example here programmatically. Are you able to understand the logic or not? Okay, no problem. So here, first of all, we have to declare a n value. Okay, you can declare a num value. Then you will have original number because you have to copy this number so that we can match it, right? So original number. Then we have a reverse number. Okay, so initially the reverse number is 0. Then we have got a remainder number. So all these variables I have declared. Now I will ask the user to enter a number for checking palindrome. Okay, so scanf %d. I will store this number in my num variable. Okay, and now I will copy this number for my reference later into my original variable. So have made it a copy. Copied it for future comparison because now this number will change. So while the number is not equal to 0, what I have to do? I have to reverse it. How will I reverse it? I will first calculate remainder. What is remainder? Num modulo 10 is my remainder. Then what is the reverse number? Reverse number is reverse multiplied by 10 plus remainder. Okay. And then once you calculate the remainder, the num will be equal to num divided by 10, the shortened number. Or we can use a shortened operation num divide equal to 10. This is also applicable. So by doing this, we have now reversed the number. If what? If original number is equal to the reverse number. So then we can printf what? The number is a palindrome. Else the number is not a palindrome. Okay. So else the number is not a palindrome. So this is how we are writing the logic. So let's give it a try, see if it is working. So let me run this code. Can you see the output screen? So here I am checking a number for 707. So it is saying number is a palindrome because it has reversed the number and said it is a palindrome. Let me close this window, rerun my code. Okay, so let me re-execute the code. So this time I will give another number, let's say 122 or 701. It's not a palindrome, right? So it is saying the number is not a palindrome. So it forward, backward, it is not same, right? So I hope you were able to understand. So what happens? Again, I'm explaining the logic to you people. First, I enter a number. So let's say the number is 707. Okay. So let's say the number is what? I entered a number, let's say 707. So now my loop starts. My loop starts with three variables. First is num, second is remainder, then we have got a reverse number. Okay, so initially my number is 707. So what happens? I get remainder. How I get remainder? 707 mod 10. So what is 707 mod 10? 7. Okay, so the number is 7. Now how do I get reverse number? Reverse number means previous reverse value, which is 0. So 0 multiplied by 10 plus 7, which is what? 7. Okay, now what I do with this number, I change it by dividing with it with 10. So now the number becomes 70 because 707 divided by 10 will be my new number, which is 70, which is the quotient. Okay, now I do the same business. 70 mod 10. What is 70 mod 10? 0. What is reverse? Previous value 7 multiplied by 10 plus 0, which is now 70. Okay. Then what do I do? I shorten my number by dividing it with 10. So 70 divided by 7, 70 divided by 10 is 7. So my new number is 7. Okay. Now I calculate 7 mod 10. What is 7 mod 10? 7. Because when you divide 10 with 7, the remainder is 7 because 10 goes 0 times in 7. So previous value 70 multiplied by 10 plus 7. So that is 707. So this is my reverse number. This is my original number. Both are same. Okay, since both are same, they are palindromes. Okay. If you do with any other number which is not palindrome, it will give the answer accordingly. Clear? Is the logic clear to you? Is it working for anyone? Okay. So are you able to understand the logic? You tell me. Okay, what about other persons? Uh, Ekta, Ganpati, Gaurav, Shandilya, Jasjeet, Netal. Why these students are not replying or not participating? Yogita. Understood? Okay. All right. If you are able to understand, comprehend, that is good. But if you are not able to comprehend, feel free to ask. Okay, this is a lab session. You can ask. Okay, please try it. Then only you will get the gist of it. Otherwise, this session will bypass like, no, you never understood. So please practice programming. Practice is the only uh, way by which you can learn programming. Okay. One more example is there with us. That is Armstrong number. See, what is Armstrong number? Again, an interesting concept. So here, an Armstrong number is nothing. When you take the cube of its digits and you add up, it gets you the original number. For example, 153 is an Armstrong number. Why? Because 1 cube plus 5 cube plus 3 cube is 153. Okay. So that is why this number is an Armstrong number. Okay. Similarly, 407 is an Armstrong number. Why? Because 4 cube plus 0 cube plus 7 cube. It's 407. Check it. 64 plus 0 plus 341. Oh, sorry, 343. So what it is? 407. So 343 plus 64 is 407. So 407 is an Armstrong number. So all these numbers are Armstrong numbers, right? There are many more, but this is Armstrong number. So same concept. What we are going to do is we are going to extract every digit and we are going to calculate the cube of it. Okay. Every time we are going to get remainder, that is extract a digit and then convert it by adding it into the result. Same logic. Okay. So once again, what we do is instead of calculating reverse, I will rename my variable as result. So initially result is 0. Okay. So I definitely will calculate remainder to extract a digit, but result will be result plus previous result plus the remainder cube. Okay. So the cube of the remainder. So remainder into remainder into remainder. That is cube of the remainder. This is what I'm doing. Or using shorthand operation, I can write it plus equal to. That is also one and the same thing. So the remaining logic is same. Okay. This is how for checking Armstrong. So the number is Armstrong. So let me run this code, see if it is working. So here if original is equal to result. Yes, sorry. If the original is equal to result. So let me share the screen with you. So I entered a number called 407. So the number is Armstrong. Okay, same logic. Just I am calculating the cube of every digit. Right? So I will share the code with you. There is not much difference. Only one line of code I have changed. Right? So that's it for today. Hopefully you were able to understand the programs. So today we have completed a while loop, for loop, do while loop. We will see more programs in the next session, which would be the last for lab. Okay. Uh, Thank you. Happy learning. Practice programming, please.